Welcome. How you doing? This is a Khan Academy support video. Specifically, we're going to be focused on this second assignment about equation solving, the one that's called equations with variables on both sides. So the challenge here is going to be the variable is going to show up now not just on one side of the equation, but as the assignment suggests, the variable will be on both sides of the equation. So here is our first example. They're using the letter E. I have a tough time drawing E's, so I'm just going to write X on my whiteboard. But it says 9 times E minus 7 is equal to 7 times E minus 11. So this is an equation that's just a number statement, and in this case what they're trying to tell us, they're saying whatever 9 times X minus 7 is needs to produce the same exact value as 7 times X minus 11. And our job is to figure out what is that X number. So that 9X minus 7 will be the same value as 7X minus 11. My goal, remember the last assignment, our goal whenever we were solving equations was to isolate the variable, to get it all by itself on one side of the equation. And in this lesson, what we see, the challenge is the variable doesn't only show up once, it shows up twice. And in this case, it showed up on opposite sides of the equation. There's an important rule in math. If the 9x and 7x were on the same side of the equation right now, I could combine them, I could add them up. They would be in the same expression. But part of the reason we draw this line through the equation, what I call the river, is it reminds me if the 9x and the 7x are not yet on the same side of the equation, I can't combine them until they do get gathered on the same side. So my goal here is going to be to get the 7x on the same side of the equation as the 9x. Personally, I always choose to move the smaller variable because that leads towards positive numbers, but I could move either one. But I'm going to move the smaller one. I don't want the 7x on the right side, and the opposite of a positive 7x would be a negative 7x. If I were to subtract 7x's from the right side of the equation, that would get rid of all of the x's that were over there and leave us with just a negative 11. But remember, I'm only allowed to subtract 7x's from the right side of the equation if I do the same exact negative 7x on the left side to keep everything balanced, to keep it all equal on the left and the right side. So 9x minus 7x, I need to combine like terms, so it needs to be put with the other x term. 9x minus 7x would give us 2x. And once I've done that, I bring down the negative 7, and now this equation, 2x minus 7 equals negative 11 should look a lot more like the equations we were working on 2 steps earlier and the ones you did last year with Mr. Neville. Now all the x's, they live on the left side of the equation for me, so I don't want the negative 7 over here. That's a constant term, a regular number, and that should go on the right side of the equation with the other constant. So I'm going to use a plus 7 to eliminate the negative 7. Again, inverse operations help me cancel things out. And if I added 7 to the left side, I need to add 7 on the right side. Solving equations, bring your negative numbers into play quite a bit. I need to know negative 11 plus 7 makes negative 4. And that's equal to 2 times x, so I get 2x equals negative 4. At that point, what number times 2 equals negative 4? I could divide both sides of the equation by 2. Or I could solve by inspection. At this point, I think a lot of you know 2 times 2 would make 4, and we need x to be a negative 2 because a positive times a negative 2 would give us a negative 4 there. So we could have divided by 2 to get to our final answer. I kind of skipped that last step and just thought about the equation to realize that x would be negative 2. So we'll make that whiteboard a little smaller. That's how I got to negative 2 for an answer. Recall that they were using the letter E. I put x on my whiteboard, but again, I can be using any letter here when it's just one variable in the equation. It looks like that answer is correct. We're moving on to the next one. Okay, as I'm erasing my whiteboard, take a look at that next equation. It says 20 minus 6 plus 4k equals 2 minus 2k. And I should have zoomed in. Give me 1 second to do that. So here's that equation a little larger for you. It says 20 minus 6 plus 4k, that's the left side of the equation, is equal to 2 minus 2k. That's the right side of our equation. So here, a couple things are going on. The variable shows up twice on opposite sides of the equation. That's a challenge we'll tackle in a second. But also, the first thing I noticed, there are 5 different terms: 20, negative 6, positive 4k, 2, and negative 2k. Anytime I see that many terms, I start thinking, are there any like terms, any of the same kind of terms, already on the same side of the equation? Because if there are, like the 20 and the negative 6 in this example, I can combine those like terms to simplify the equation, to make it easier to work with. 20 minus 6, two regular numbers that are both on the left side of the equation, would combine to make 14. So this does not have to be your first step, but for me, I think it makes the most sense here to simplify, to combine the 20 and the negative 6. So now I have 14 plus 4k on the left side of my equation needs to be equal in value to 2 minus 2k on the right side of the equation. I would love to combine these k terms because my goal is to get the k all by itself, so I need to combine all the k terms, but they're not on the same side of the equation yet. So my goal is to move them around. Again, I'm going to choose to move the smaller k. I'm going to move the negative 2k, and I'm going to do that with a plus 2k. I could have tried to move the positive 4k. That would have been with a negative 4k. That would have produced a negative number, which is fine, but I would like to stay with positive, so I'm moving the smaller k. I'm moving the negative 2k. It shows up as a positive 2k on the left side of the equation now. It used to be a negative 2k. Now as we add 2k to the right side and the left side, it shows up as its opposite self on the left side of the equation. 4k plus 2k becomes 6k. So I have 14 plus 6k is going to be equal to 2. Now, you'll notice we've gathered our k terms. The variable term is living on the left side of this equation. So the 14, a constant, a regular number, should not be on the left side of the equation. To get rid of a positive 14, I use a negative 14. 14 minus 14 would cancel out and give us nothing. So that isolates the 6k. But I need to remember to subtract 14 from the right side of the equation as well. 2 minus 14, that's similar to 14 minus 2, which would be 12, but this is the opposite. It's 2 minus 14, so we get a negative 12 there. 6 times k equals negative 12. What number times k, or sorry, what number for k multiplied with 6 would make negative 12? I'm going to try to go quick here. I think 2 times 6 would give us the 12, so k must be equal to 2, I think. So I'm going to plug that 2 in for k, see what happens. Oh, give me 1 second. Plug that 2 in for k, and just give me 1 second to bring that to the top, and I'm going to check that 2 for k. And oh no, Khan Academy tells me I'm wrong. It says not quite, try again, get help. This is going to happen for you all a lot, I think, as you're practicing on your own at home. I cannot emphasize enough, you need to be clicking the get help function. You need to be trying to get help from Khan Academy on your own. So I'm going to dig in, click get help. I'm going to look through their work, and I'm going to try to see what they did. The important thing to understand for Khan Academy here, carefully go back to the top and read through each step. They number them here. So they say 1 out of 3. They say we need to manipulate the equation to get k by itself. That's what we're talking about with isolating the k. And so we see the first thing they do here, they say 20 minus 6, and I'm going to pop up my whiteboard again for a second time now, is we're taking a look at them. The first thing they did, they said they combined like terms. And for combining like terms, we'll take a look at our whiteboard here. They had the same first step as me. They take 20 minus 6, they combine it, and that gives them 14 here. I see the next step, and I start reading through all their steps carefully, step by step, and I see, oh, they added 2k to each side of the equation here. They're showing a plus 2k on both sides of the equation on that step. And I see that same plus 2k on both sides. So I keep going through. I see here, by the time I get to the bottom, it says 6k equals negative 12. 6k equals negative 12. That's the same thing that I had in my equation. They say divide each side by 6. I kind of skipped that last step. If I divide each side by 6, I see, oh, it should not have been 2 because that negative 12 was there. K needed to actually be a negative 2. So again, I cannot encourage you enough, please, whenever you're making small mistakes here on Khan Academy, read through their work. See what they say, make sense of it, so that way you can learn from the mistake and figure out the next problem on your own. So that helped me find where I lost the negative sign. I realized negative 2 is the right answer. It's okay if I miss 1 or 2, especially because I can do these assignments over, and there are only 4 questions. We're going to show one last example here. I'm going to encourage you right now to pause this. I think you could probably do this one on your own, or at least think about what would your first step be to solve this equation. 2d plus 4 is equal in value to 10 plus 5d. There's a bunch of different steps you can take. Our goal here is going to be to get the d values, the d variables on the same side of the equation, and then regular numbers on the opposite side of the equation. I'm going to move the smaller of the 2 variables. When I see 2 variable terms on opposite sides of the equation, I choose to always move the smaller one. So I'm going to move the positive 2d, and the way I cancel that out from the left side of the equation, let me make that whiteboard a bit larger as we go through it. The way I cancel that out from the left side is to subtract 2d, because that would eliminate a positive 2d, and then I need to do the same negative 2d on the right side of the equation. I get 4 on the left side of the equation is equal to 10 plus 3d. Now 5 minus 2, I get 3, so 3d left over there. Here we see the variable is living on the right side. I want to isolate the variable on the right side, so the first layer I want to peel is the positive 10. I can get rid of a positive 10 with a negative 10, so I'm subtracting 10 from both sides of my equation. 4 minus 10 is a lot like 10 minus 4, but the opposite version of it. It's going to produce, or sum to make, negative 6. The negative 10 cancels out the positive 10. The only thing over here now is the 3 multiplied with d. Here, after I made that mistake the last time, I'm not going to skip the last step. I'm going to go ahead and divide both sides of my equation by 3. I'm going to be a lot more careful now, remembering that I lost the negative sign last time. What number times a positive makes a negative 6? I know already I need to be getting a negative answer here in this case. The variable d has to be equal to negative 2. If you really want to make sure you're correct before you plug that answer in, you could put a negative 2 up here. 2 times negative 2 would be negative 4. Negative 4 plus 4 would be 0. Over here, negative 2 times 5 would be negative 10. Negative 10 plus 10 would also make 0. The left and the right side produce the same thing. So again, if you want to check if your answer is correct, and I ran through too quickly really there, but take the variable answer, plug it back into the equation, and see if the left side really does make the same number as the right side. I'm going to put negative 2 in for our final answer. That's going to be the last example we go through for this. Thanks for watching to the end. If you've got questions as you're working through this assignment, I would encourage you to read their explanations with the Get Help feature that I showed you. Feel free to try to search up and find Sal Khan's videos that are right attached to this, and you can also always email me and ask for some help on Zoom or on Google Hangouts. Hope you're doing well. Thanks for watching to the end.